Hey guys, this looks like a fun one. We're given three squares inside of a circle, and it wants to know what is the area of the circle. This is day 17 of the 2025 Advent calendar, and it's my goal to solve all these by Valentine's Day 2024. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. Since we're given that this is a square, this side will also be equal to 6. And then for this square, since this and this are both 6s, this will be a 12. And same thing for this side and this side. They'll all be equal to 12. And then for the bottom square, since this is 6 and this is 12, this will be equal to 18. And the same thing for this side. Now from here, I want to focus on this top square. Let's extend this side of the square all the way down to here. Now this inscribed angle is going to be a right angle because it's one of the angles in the square. And then we can connect this point to this point. This will end up being a diameter of the circle. Anytime you have an inscribed angle that's a right angle, it always stands on the diameter of the circle. Here's some notes right here. Let's label the diameter 2r. And now we can write a formula for the area of this circle. It's going to be equal to pi r squared. This looks important. Let's put a box around it. Next, I want to see if we can do the Pythagorean theorem with this right triangle. This smallest side is going to be equal to 6 because it's one of the sides of the square. And then this piece of this side is equal to 6. This piece is equal to 12. This piece is equal to 18. And then we don't know anything about this last little piece. Let's call it x. Let's clean this up a little bit. The 6, the 12, and the 18, all of this will become 36. And now we can do the Pythagorean theorem. It's going to be 6 squared plus the quantity 36 plus x squared equals the quantity 2r squared. Right now, this is an equation with two variables. Let's copy it down here and deal with it later. And let's see what else we can do. We already have this chord here. Let's focus on this intersecting chord. Since this is 6 and this is 6, this is going to be equal to 12. And then since this is equal to 6, this will be equal to 6. And now we can solve for x using the intersecting chord theorem. Here's the notes right here. Anytime you have two intersecting chords in a circle, it's always true that this times this equals this times this. So using these notes, we can say 36 times x equals 12 times 6. And then to clean this up, 12 times 6 is equal to 72, and then we can divide both sides by 36. And that's going to give us x is equal to 2. And now we're ready to work on this other equation. In the place of this x, we can plug in 2. 36 plus 2 is equal to 38, and 38 squared is equal to 1,444. 6 squared is equal to 36, and 36 plus 1,444 is equal to 1,480. And then on the right-hand side, the square can go to each of these, giving us 2 squared r squared. 2 squared is equal to 4, and then we can divide both sides by 4. On the left-hand side, 1480 divided by 4 is equal to 370. And the right-hand side is equal to r squared. So now we're ready to plug it into this equation. In the place of this r squared, we can plug in 370. That'll give us an area of 370 pi. That is the answer to our question. Let's put a box around it. How exciting. And here's the next question. We're given 3 rectangles and we're told they all have the same area. And it's asking what is that area? These 2 rectangles have a height of 10 and this one has a height of 7. This looks like a fun one. How exciting.